So it's fantastic to see everybody. My name is Liz.
And I'm Charlie.
And we are members of the NRICH team based in Cambridge. Some of you may have come along to one of our webinars before. You're very welcome here again, but please don't worry if you've not. We hope you enjoy this afternoon's session. So we must say a huge thank you to Trinity College here in Cambridge, who fund these webinars so that they are free to you as participants. We really appreciate that, so thank you. So this afternoon, we are focusing on nurturing young mathematicians. So here at NRICH, we believe very firmly that there's more to being a mathematician than having a deep conceptual understanding, more than being fluent with perhaps mathematical procedures or having that flexibility in manipulating numbers, for example. There are other elements to being a mathematician, and we've developed a model which we'd very much like to share with you to help us think about this. So what I'm going to do is I'm going to share my screen and take us to a place on the NRICH site. Here we go. So what I'm hoping is that you can see our article here. It's entitled Nurturing Successful Mathematicians. We will show you where you can find this towards the end of the webinar. If I scroll down, I'm hoping that you can see this image. So we've developed an image of a three-strand rope to help us think about developing young mathematicians. Now, we should say that this model is based on a rope model that was originally created by Kilpatrick and colleagues back in 2001, possibly. But we've been doing quite a lot of thinking about it recently. And this three-strand model really reflects our current thinking. So you can see there in the middle, the conceptual understanding and fluency strand, and then to the left, the mathematical thinking strand, and to the right, mathematical mindsets. So the really important thing, there are a number of features of the rope that we'd like to draw to your attention. So each strand complements the others, and they work together to contribute to the strength of the rope as a whole. Charlie, is there anything else in particular you'd like to say about the image?
No, but I suppose the message that we're going to be sharing with you today is that offering students tasks which allow them to work on all three strands at the same time, well, I suppose is the only teachers are short of time.
Absolutely.
And what we aim to do with rich tasks on NRICH is offer tasks that offer students a chance to work to strengthen all three strands at the same time.
Absolutely, absolutely. Thank you. So in order to help us think about these three strands, we this afternoon are going to particularly focus on the mathematical thinking and mathematical mindsets. We're confident that the understanding and the fluency are parts of mathematics teaching and learning that you are confident about addressing yourselves. We can draw on resources to help in those aspects relatively easily. There are many resources out there that you as a school might use. So our focus this afternoon is on the thinking and the mindsets. And in order to reflect on those two aspects, we're going to have a go at a couple of tasks this afternoon. Now, the important thing to say, I think, is that we have chosen some tasks which we think will provoke some interesting conversations around these aspects of the rope. But we're mindful that you as teachers are good mathematicians. So although the tasks we've chosen particularly will be suitable, I would say, roughly for students, sort of in mid-primary upwards, I want to reassure you that if you're teaching much younger children, there are resources on the NRICH website for you. And similarly, if you're teaching students, post-16, there are resources on NRICH. We've chosen ones that we know we will be able to work on all together as a mixed group. So Charlie, are you ready for our first task? So this task here is called Less is More. Now, as Charlie said, all the NRICH tasks that we're going to share with you offer opportunities to develop the curriculum knowledge at the same time, and we will show you how these tasks link to the curriculum towards the end. Less is more. So Charlie, we've got an interactivity to use here, which allows us to take these 8 digits at the top, and we're going to create 4 two-digit numbers. We want to place them here so that our inequality statements are correct. And I wonder whether you could, have a go. Start us off.
Okay. I think 14 is less than 35.
Okie dokie, I would agree with that. Yeah.
And 33 is less than 56.
Okay. I would agree. I think you've made both the inequalities true. I have to say I was a bit sneaky and I didn't quite give you the full picture. In fact, you're going to be given a score for this game, and your score is the sum of the two-digit numbers on the left here. Assuming that your inequalities are true, your score is going to be the sum of these two-digit numbers. So I think in this case, we've got a score of 47.
Yes.
So I'm going to click the submit button. Okay, so the computer is telling us, yes, you scored 47. But now you know, actually, that is our score. The computer is challenging us. So we're being invited to have another go. Can we rearrange those numbers and get a bigger score? So we're going to use those same digits. So I think Charlie needs a bit of help. Those of you participating, have a go. We're going to try again. What I'll do is I will drag these numbers back up here. Can you have a think? How could you arrange these 8 digits to make these 2 inequalities correct, but maximize your score?
So the challenge is to make the numbers on the left smaller than the numbers on the right.
Yep.
But make them as large as possible.
Exactly that.
Okay.
So what we'd love you to do, please, is have a think and post in the chat now. Please, if you could post your total, we would very much appreciate it. Don't give away the score, I beg your pardon. Don't give away how you've arranged your numbers yet. So please just post your total. Charlie, I've already forgotten what you got. Was it 47? 30,
Yeah.
47.
Yes.
So that's score to beat. We'll stop talking for a few moments and give you a chance to have a go. So we're trying to pop those 8 digits to make 4 two-digit numbers, but we'd like the total on the 2 two-digit numbers on the left to be as high as possible. 47 is what we're trying to beat.
Somebody scored 67, that is better. And I think I might be able to guess what they did. They might have had a 33 and a 34 on the left.
Maybe.
Because that would get 67.
So is that the highest, do we think?
Well,
I wonder.
other people have got numbers which are high, totals which are, we have a 76, we have a few people, somebody's got 86, someone's got 88.
Okay. So let's
Someone said 119, which seems unlikely given the numbers that we have.
Yeah, so I would say so. Remember, the score is the sum of the two-digit numbers on the left-hand side.
And you've got to use all 8 digits that you're given.
Yes, we didn't specify that actually, did we? Okay. So a little bit longer to think.
So lots of suggestions in the 80s, 90s. There's a 76. I think I can predict. Shall we try and do the 76?
76, okay.
I think there'll be a 43 plus, and a 33 on the left.
Okay, 43 and a 33. And so as long as
as long as it's correct,
yeah,
we're going to get a score of 76.
So I mean, I could just put 50s because
yes,
I know that that's going to be bigger. So that is one way.
That's definitely possible to score a 76.
But I mean, shall I submit and see if that's the highest, Charlie? Or would that be, maybe not, maybe not.
Well, somebody's got an 86.
Oh, okay.
So, okay, shall we try and see? I think if we replace the 4 and the 5.
Yes. Can we do something like this then? And then we'd have to put the 6 here.
Yes.
Maybe.
So, I mean, that may not be what they did.
It may not be, but that is one way of getting 86. I guess in the classroom, what we'd be doing, Charlie, is we'd be encouraging children to work in pairs, to chat about their ideas, to reason. You know, articulating your reasoning can really help clarify in your own head, and it can, you know, spark ideas in your partner.
If you swap the 3 and the 4 in the top row, we get 87.
Oh, good point.
Which somebody else has got.
Nice. So we've taken it up a little bit.
Yes, but somebody wrote 88.
Oh, okay. 88.
If we swap the 5 and the 4, that 5 and the 4.
Yeah. Oh, yes. Oh, yeah. Yeah.
We've got 88.
So we're creeping upwards.
Yes, yes, yes. Oh. There are several 96s. I wonder, could anybody who didn't get 96 try and figure out how it's possible to get 96? Or can they? Yes. I wonder, is 96 the highest? Somebody's got 107. Wow.
107.
And there's an 80, 90. Okay, several 96s. Shall we ask?
Yes.
One of the 96s.
It's got 96. I wonder whether you could pop in the chat
what your 2 numbers on the left are.
What your 2 numbers on the left are. Let's have a little think together.
I imagine we'd be able to work out the numbers on the right.
I would imagine so too. Okay. 53 and 43. Right. 53 and 43. Okay.
Yeah.
Right. So that top one stands, and yeah, that's going to work, isn't it, Charlie? Because I can make 51 there.
Yes.
So that's one way of doing it. Again, I could, in this case, actually have swapped those 2 ones, couldn't I? But I would still get interesting. So is 96 our top?
Shall we try? Shall we submit?
Let's submit. Oh, fantastic, fantastic. That's the interactivity here is really helpful, giving you that kind of feedback. And if we hadn't got, like we saw the first time round, we weren't told what the highest score was, crucially. We were just given that little bit of motivation to keep going.
Yes. And I can imagine if I don't have the highest score, but other people in the class have got the highest score, wanting to figure out how they got it.
Yes, that's right. So Charlie, this, as I mentioned at the beginning, this task is a really lovely task, as is for, you know, sort of middle, upper end of primary.
And it can be done in different ways.
Absolutely.
We did it by being given all 8 numbers at the beginning.
Yes.
You can imagine doing this in a class with students, giving them dice.
Yeah.
And as they throw the dice, they've got to decide where to put the numbers in advance.
Straight away, yes.
Not knowing what are the other numbers, so there's a bit of probabilistic thinking going on. And playing a game, and maybe getting students to work in pairs.
Yes.
Either against other pairs or just collaborating to work out the highest score. And and in the problem, we've suggested different ways.
We've suggested a few different ways of, and of course, you don't necessarily need the interactivity to play in those ways.
Now at NRICH, we talk about low threshold, high ceiling tasks, and so after getting very excited about this problem, we wanted to do more. So this problem is called less is more. and we created a problem called more. Less is more.
Which is linked from the bottom of this one. So let's have a little look at, again, we've got an interactivity.
And
Actually, I might scroll down just to give us a bit of a sense. So more, less is more. It comprises 4 different versions, if you like, 4 different challenges, and you get a snapshot there. Now, in exactly the same way as previously, it's the, if you like, in this case, it's the result on the left, which is your score, and you're trying to get the result on the left as high as possible while still making the inequality correct.
Okay. We're not going to have time to do all 4.
We're not,
but we thought that take would be a good one to do.
I think that's good. So if we go up to the interactivity, the default is on sum, so this version, but let's give you a little bit more of a challenge. We're going to choose take. We'll stick to numbers 1 to 6, but we could have chosen 0 to 9. Okay. Right then, Charlie. So I think we can challenge everybody straight off, I think, here. Can we arrange your challenge is to arrange those 8 digits to make the 4 2-digit numbers below so that the inequality is true, but also that your score on the left, so the result of the subtraction on the left, is as large as possible. So again, in the same way, have a little think, and on the chat, if you could post your score. So,
but don't give away how you
did it initially. We'll leave you to have a little think. So Charlie and I are having a think. So just to reiterate, we're placing those 8 digits in the 8 boxes. We want to make the inequality statement true, but we're trying to make the result on the left as large as possible, highest score. We've had a few contributions so far. I do like the question marks, that slight uncertainty implied there.
Okay. The answer cannot be in the 100s because we're going to subtract a 2-digit number from a 2-digit number. And, even if you had 99 take away 11, you'd end up with less than 100.
Yeah.
So
we have no negative numbers here. Yes. No, sorry, Lois. Perhaps I haven't been clear enough. Apologies. So we have got a 2-digit number here. Take away this 2-digit number. So you're subtracting this 2-digit number from this first one to give your score. And that score there is less than the difference between these 2-digit numbers on the right. But you're trying to get your score as high as possible. At this stage, please don't give away where you've placed your digits. Just give us your score. So just give us the result of the subtraction on the left, please. We've got 26. We've got 32. We've got a 33.
I'm not sure I used all the numbers correctly here.
Has Charlie been cheating? Let's see.
2 2s, 2 3s.
Shall we have a little look?
So one of the first solutions we got was 26.
Yes. So how could we get a difference of 26, I wonder?
Could we ask Mrs. Jones to
Yes,
tell
let's
us?
look. Mrs. F. Jones, I'm sorry, we don't know your name other than what is up on Zoom. I wonder if you could tell us what you put on the left-hand side, please. Which were the two-digit numbers that you used to get your score of 26? I do like the fact that in both of the tasks we've done so far, the both versions, people have changed their mind and adjusted their thinking, which is absolutely fine and exactly what we would expect to happen in the classroom.
I'm thinking of a pack of cards.
Oh,
Yes.
don't worry, Mrs. Jones. You had 62. Take away. Let's have a little look. Should I just? You're saying that you made a little mistake.
Minus 36.
Don't worry. Don't worry. We all make mistakes. 52. Oops. Take away 18. Unfortunately, we've got the digits 3 and 4 left. So we can't have an 18 on the other side. Oh no. Oh, you've said 34. I beg your pardon. I've now seen. So that was the what you have suggested. But I think you're saying that your reasoning is not correct.
I think the right-hand side is
not small. It's not bigger than the left-hand side.
Yes.
Yes. Okay.
But I was thinking about a pack of cards.
Oh yeah.
Has 52 cards, and half the pack is 26 cards.
Yes.
And so that will give me 26.
Nice.
And I imagine that's going to be bigger than
26.
Than 63 take away 34. So I scored 26, but
You did score 26. Then nice. Nice.
And I expect this will be students' experience, that they have a go and then they get told, oh, you could do better.
Absolutely. Absolutely. The aim of this, when we're first being introduced to a task like this, it's not about it's about straight away getting the higher score. We want students to test out their ideas, and by testing them out, they then begin to reflect and develop some strategies. It won't happen straight away.
I mean, it's very satisfying getting it right first time, right?
It is very satisfying.
But
we shouldn't,
Yes.
It's quite easy to convince yourself that you think you've got the highest.
Yes.
Not have.
Actually, we were working with a group of adults the other day who were told what the highest was, and they still wanted to improve on that.
Yeah.
They spent the whole coffee break. Okay, some people got 41.
Do we think we could try 41?
Can somebody post?
Yeah.
Well,
could somebody who's got 41 think
yes, 65
their left-hand side?
Okay, so I think 64.
Thank you, Lois. Okay, yeah, I see. Oh, try again. Try again.
64 take away 23.
There we go. And then 65 take away 23.
That's interesting.
That's rather nice, isn't it?
The number on the right is just one more than the number on the left.
Yes, we're taking away the same. Yes, that's
And it does. This is why it's in the mapping document under place value, because often students realize the importance of the numbers you put in the tens column.
Yeah.
So those cells tend to have a greater impact than the numbers in the units. So they're much more significant. Yeah. So though we may not use the language of significant figures, it is intuitive here. We're going to submit?
Yep, let's submit.
Yeah.
Hey, okay, that's quite satisfying, isn't it? So now, obviously, we could spend a lot more time on this task, but we're going to pause there. Again, by the way, you can see some ideas about how you could use this away for the computer. You can play in very similar way that we described earlier.
And the purple pog shows you
the different options.
Some, take.
That's right.
Take some and some take. Okay.
But let's pause the mathematics there. Having had that experience of working on those two linked tasks, let's return now to our rope model. For the purposes of this first part of the session, we'd like to focus on the mathematical mindsets. So at NRICH, we've thought about 4 particular mindsets. So these are the 4 that we've chosen to discuss in detail. So we would like our students to be curious, to work collaboratively, to be resourceful. So in other words, they would have a range of strategies at their fingertips for tackling a problem, so that if the first way they tried didn't work, they could draw on another way. And being resilient. So of course, that idea that having been resourceful, so I might try a different way, but then I look for other ways, I keep going, and I don't give up easily. So if we bear in mind those 4 mathematical mindsets, what we'd like you to do is think about your experience of working on that task and take your mind to the classroom. And which of these mindsets do you feel could be strengthened by working on this task with your students? We'd love it if you could contribute your thoughts via the chat, please. Please don't feel like you have to write reams and reams, but a few words of explanation would be really helpful. Charlie, did you want to?
So we often think about the threads of the mathematical mindset strand.
Yes.
So
yes.
Which of these 4 threads will students be tapping into?
That's right.
Which 4 threads would be nurtured, would be strengthened if when you give students a problem like this?
Exactly. So we'll give you a few moments to contribute.
This is great. We've had suggestions that it taps into curiosity, resourcefulness, and resilience.
I'm sorry, I think I perhaps haven't been clear enough. Although we can see in our rope model on the screen both the mathematical thinking strand and the mathematical mindsets, just for the purposes of here and now, we're going to focus on the mathematical mindsets in the context of the less is more and more less is more problem. So I'm really pleased that you're having a look at the mathematical thinking. We'll get a chance to look at mathematical thinking in more detail with our second task. So just focus on the mindsets. Which of these could we nurture through those problems? Once you've posted your own ideas, do scroll back through the chat because people have, as Charlie says, contributed different thoughts.
This is great. There's talk about being curious. When you know that a classmate has got a higher score than you have, you're going to be curious about whether you can improve.
Absolutely.
There's been talk about being collaborative, because in the classroom you may well get students working in pairs.
That's right. Yeah.
Resourceful, because you've got there is not one single way of approaching a problem like this. Which digits you choose to start with may vary depending on which digits you have, which problem you're working on. Do you do the left-hand side first and then the right, or do you do the tens column first and then the units? Do you use the biggest numbers for take? You want 2 big numbers in the tens columns, and you want in the tens column at the start of each, but there's what smaller numbers in the tens column that you're subtracting. So there is not. I just think that when there's a standard way of solving standard problems, you're not required to be very resourceful.
Absolutely.
You know what to do.
Yes.
You're fluent at it,
Yes.
and
Yes.
you've rehearsed it several times.
Yes.
Here, I mean, every time you get the new set of numbers, you think, "Oh, am I going to be able to do this one?"
Right. It's a new challenge. It's a new challenge.
Every time, and you're not
Yeah.
quite sure how you're going to approach it.
That's right.
And the resilience, a lot of people have talked about it
Yeah.
because you don't always get it right the first time round,
No.
and you try again. And
And
somebody said,
that's been
try
said.
and try again.
Try and try again. And also, as somebody has pointed out just now, that the fact that in the particular task we just shared with you, you're getting that feedback that we mentioned. You know, you haven't got the highest, but you're not told what the highest is. So you're given that bit of encouragement, aren't you, to keep going. We're very much at NRICH, we think quite hard about how to encourage our students to keep going without providing them with too much scaffolding. It's that balance, isn't it? Okay. Shall we have a go at another task, Charlie?
Okay, so the reason we chose that task was it's a really good example of offering students an experience of working on a problem that gives a teacher an opportunity to recognize the value of being collaborative, resourceful, resilient. In a way, I suppose some of it is the responsibility of the teacher or of us to give students problems that intrigue them, that have a hook, that tap into their curiosity. But as teachers, we need to celebrate students' resourcefulness, resilience, ability to work collaboratively, um, uh, to listen to each other's ideas and so on, and discuss and share, convince each other of what to do.
That's right. We'd like to reassure you that we have created guidance, and there are recordings from previous webinars, each one focusing on one of the mindsets and one of the thinking skills. We'll show you where to find those towards the end of the webinar. Okay, task number 2.
Okay.
Now, I'm not going to share this initially on the website. I think what we might do is look at, use the visualizer to look at a piece of paper, and we'll do it in real-time writing. And now I'm hoping that's going to work. Okay, there we go.
I'm just going to...
That's better.
That's about right.
Yeah.
Okay, so I'd like people, can we have it a little bit higher? To contribute, so that we can get more of the page. 2 consecutive numbers where the first number is a multiple of 2 and the second number is a multiple of 3. And can you put some suggestions in the chat?
Thank you, Becky, for kicking us off. 2 and 3, we've got. 8 and 9. 20 and 21.
People have been quite safe so far. One challenge you might give students is, can you put a pair that you don't think anybody else is going to write? Or can you put a pair where both numbers are greater than 1,000? We've got a 302, 303 from Billy.
Nice.
Okay, I think that was too easy.
You think?
So let's go for 3 consecutive numbers now. I'm just going to abbreviate
Yeah, yeah.
multiple. So a multiple of 2 followed by a multiple of 3 followed by a multiple of 4.
Okay, 3 consecutive numbers, multiple of 2, multiple of 3, multiple of 4. Again, if you could pop your suggestions in the chat, please. 2, 3, 4. Take that and 14. 14, 15, 16. 74, 75, 76. 26, 27, 28. I haven't got that one, do we?
Joe has noticed that all our multiples of 3 so far are odd. And I'm just noticing that in our mathematical thinking strand of the rope model,
Yep.
we're exploring and noticing.
Yep.
And Joe has noticed that so far all our multiples of 3 are odd. So can anyone find 3 consecutive numbers where the first is a multiple of 2, the next one's a multiple of 3, the next one's a multiple of 4, where the multiple of 3 is even? And if not, why not? Is it impossible? Somebody said, I have missed 26, 27, 28. I don't know. Oh,
Maybe it just wasn't visible on the screen.
okay.
I think we're okay. I think we're okay, maybe. That's some nice reasoning coming in here.
So Joe has tried to explain that, possibly in secondary school language, but
I think Billy has articulated it in language that could be comprehensible to younger children.
and what that makes me do is look at the previous sheet.
Oh, yes.
And I hadn't noticed that in the previous sheet because the first number is an even number.
Yes.
The next number has to be odd. So all multiples of 3 were odd.
Very odd.
Nice.
To be fair, I think somebody did point that out and we didn't pick up on it. But anyway, yes, Mrs. Jones, that's a nice articulation as well. Yeah, of the same.
Shall we try 4 consecutive numbers?
Why not? We're
Okay.
on a bit of a roll.
Okay.
So we're having 4 consecutive numbers.
So a multiple of 2. Oops, sorry. Multiple of 2, multiple of 3, multiple of 4, multiple of 5.
Okay.
And I suppose one question you might start asking yourself is, goodness, is there an easy way of doing some of these?
Yes.
You know, is Charlie going to carry on making our consecutive numbers list longer and longer? What can we learn from what we've done so far?
Oh, we've got a few suggestions coming in. Oh, interestingly, the same one. 62, 63, 64, 65.
And Becky has said a multiple of 2, one more than a multiple of 2, a multiple of 4, and one more than a multiple of 4. So Becky, if my multiple of 4 was 12,
if x was the same value here, I'm not sure that would
yes, I'm not sure it's always going to
work.
work.
No, I don't think it will always work.
But Joe is noticing that I could have 2,
Yep.
3, 4, 5, and then 60 more than 2, 60 more than 3, 60 more than 4, 60 more than 5, or 2 lots of 60 more than 2, 2 60s more than 3, 2 60s more than 4, 2 60s more than 5.
So why the gap of 60? Don't apologize, Becky.
No, I think Becky, what you've done is right, but not sufficient. I think
Okay, that's a good way of phrasing it.
it's necessary. It is the case that all the examples that we're going to get do satisfy your rule, but I don't. But I think, I've got to go and scribble.
Yeah, I think we'd need to have a sort of a breakout room to investigate that.
But I think what's interesting here is that these are sort of going up by 60s.
Yes.
And it's making me wonder, well, was there something similar going on
Previously, in our
the
previous
examples?
Okay. Maybe, shall we write them in numerical order?
I think writing them in order.
Yeah, okay.
Because we talk about working systematically sometimes.
Yes.
So 2 and 3 were the smallest pair.
Yep.
8 and 9
Yes.
went up in 6s. Could we carry on going up in 6s?
So 14 and 15, which was one of our examples. Yeah.
20 and then 20 and 21, which is this one.
Yeah.
2, 3, 8, 9.
And then we've got the 26 and 27, which we had as well.
Here we are, yes.
Yeah. But if we added another 6, I think that would take us to what, 32? Yep, 33, which we didn't have. But it does work. Yeah, so that's interesting.
So this is going up in 6s.
Yeah.
This one went up in 60s.
Yeah.
What did the other one go up in? So we are tapping into curiosity here.
Totally.
But we are going to be thinking about thinking. Okay, I'm going to write these on a different sheet of paper, I think.
So 2, 3, 4 is the smallest.
Yes. What's the next?
The next ones we've written down is 14, 15, 16.
Okay. And that is 12. Let's keep going up in 12, shall we?
Yeah. So that takes us to 26, 27, 28, which we did have.
You had these.
Yeah. So then it will be 38, 39, 40, which we also had.
Wow. So this working systematically here.
This is really nice though, Charlie, because of course, as a whole group, imagine the classroom scenario. In this case, you've been working as individuals, but in the classroom as pairs, we might be generating some examples. We'd be pooling our examples on the board, perhaps, in exactly the same way as Charlie's done on these pieces of paper. But now Charlie is helping make sense of these and ordering the recording to enable you, students, to begin to notice the patterns. And now we can think about, okay, why?
I'm trying this. I wrote too big. I'm really sorry.
It's fine. It's fine.
So these are multiples of 2 and multiples of 3.
Yeah.
And these were multiples of 2, multiples of 3, multiples of 4.
Yeah. And then we've got we can't quite see them. So let me see if I can adjust a bit.
Oh.
So excuse the wonkiness.
My board work is a lot better than my paperwork.
There we go. We've just about got that in. Just about. So
the question that we might be asking ourselves, why is this happening? Why are we always going, lots of questions.
Lots of questions.
With the first one, are we going to keep hitting pairs of consecutive numbers
if we
go up in
sixes.
sixes,
Yeah.
where the first one's a multiple of 2. Once we've got 1, is it inevitable that we're going to keep hitting?
Right.
And here where we've got 3 consecutive numbers and we've got 1 set where the first is a multiple of 2, then 3, then 4, is it a certainty that as we go up in 12s, we're always going to get other sets that satisfy the criteria, and here 60.
So we've done some generalizing, we've created these conjectures, Charlie, but now there's some work to do here, isn't there? In perhaps we could use, in using some visualization, some representations to work through our conjectures to actually lead potentially to some more rigorous explaining and maybe some proof.
Now you've got some Cuisenaire rods.
I've got some Cuisenaire rods.
Can you use them just to explain the very first example?
I think we could use them to explain the very first example. I think you've got my little set of Cuisenaire rods. Did you? It's all okay. We're under control. Did you tap?
I've got no. Oh yes.
Yes. Was there a lid of them? There we go. Thank you so much. Thank you so much. Okay, so we're going to imagine, Charlie, in this example, we've used multiples of 2 and multiples of 3. So I've got some Cuisenaire rods that are length 3.
Shall I put them on white paper?
Oh, that's an excellent suggestion. So they stand out. Yeah, really good idea. Okay. So here, so I'm building, I can build my multiples of 2 by making a nice train. I like to think of them as trains when I use Cuisenaire. So this is representing 2, 4, 6, 8, and in a similar way,
I'm just going to leave just a touch, little gap between them so that everyone can see the gaps.
Yeah, nice idea. And in a similar way, I can build some chains of multiples of 3. So I've got my 3, 6, 9, 12. So we've got a nice demonstration here, a nice model to show that we've got. Let me see. I might put a few more in. So our starting point is a multiple of 2. Yes, keep going. A multiple of 2 and a multiple of 3, which are 1 apart, so they're consecutive. So what we're looking for now is our sorry, did you want to do something?
Well, I was going to write our first pair was 2 and 3.
Okay.
And then we're going to...
that's nice. And adding on, that's really helpful. Thank you, Charlie. That makes it easier to think about.
Can I just...
Please do.
So if I add 6, I'm adding more 2s.
A multiple of 2, yeah.
And if I add 3s, 2 3s, I'm also going to... So
because these are exactly the same, we're still going to have the 1 difference. So they're still going to be consecutive numbers. And
because I've started with a 2 and I'm adding more 2s, I'm going to get another multiple of 2.
Exactly that.
I've started with a 3 and I'm going to add other multiples, other 3s, I'm going to end up with a multiple of 3.
Absolutely.
So every time I add another 6, the top row is going to give me a multiple of 2, and the bottom row is going to give me a multiple of 3.
Exactly that. Now,
so
go on.
What was happening in the other 2 examples?
Let me take this out of the way.
Here we would be, to get from 2 to 14, we're adding lots of 2s.
That's right.
From here to 3 to 15, we're adding lots of 3s. And from 4 to 16, we're adding lots of 4s.
Yes. So this difference is a multiple of 2, a multiple of 3, and a multiple of 4.
So we're adding 6 2s, we're adding 4 3s, and we're adding 3 4s, and we're going to get another set, and we're going to be able to carry on doing this.
Exactly.
And this one, we're adding 30 lots of 2, 20 lots of 3, 15 lots of 4, and 12 lots of 5 when we add 60.
Exactly.
So we're always going to get another set that satisfies the criteria.
Right.
Now, the final problem in this,
Yep.
final question in this problem, I'm not sure we're going to have time to do it right now,
No. One to leave you with.
is can you find 10 consecutive numbers where the first is a multiple of 1, the second is a multiple of 2, the third is a multiple of 3, the fourth is a multiple of 4, dot, 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 dot. The eighth is a multiple of 8, the ninth is a multiple of 9, the final one is a multiple of 10. Apart from the very obvious one,
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah.
What other sets of 10 consecutive numbers can you find which satisfy those conditions?
Yes, and in the classroom, depending on your students, you might even start with that version of the problem and give students a short time to think about it, to put them in the position of having to really grapple with an idea, but then inviting them to park their thinking and introduce them to what we've just done here so that they would have some insight, they would have some examples to work from, which would, what we hope you will find is actually what sounds like an extremely challenging problem unlocks after you've done the generalizing.
Yes, if we'd started with this final question and given students, we didn't want to do that with you because it was going to take too long, but you can imagine students struggling. And we've recently been reading two books, one called Productive Struggle and the other one, Productive Failure, both of which suggest that giving students a task that is slightly beyond their reach initially
Yes.
makes them aware that they need to learn, need to know. Because I imagine doing this final product and randomly trying to find 10 could be really frustrating because you might find a set, yeah, the last one's going to be a multiple of 10. So you choose the multiples of 10 and you work backwards. And well, the one before is not a multiple of 9, but you might choose, okay, 999 is a multiple of 9. So that could be the ninth number. And 1,000, okay, is 998 a multiple of 8? Oh, no, okay, I've got to try something else.
Yes. Yeah.
And the suggestion that you start with a hard problem. And then, like you said, you put it to one side, you work on some simpler problems, you explore, you notice, you conjecture, you test ideas,
Yes.
you look at ways of representing what's going on.
That's right.
And then at the end, you go back to that.
That's right. Charlie, you've led us very nicely into going back, I think, to the our model,
Yes.
our rope model. So now we're thinking, as you can imagine from what we're saying, we're thinking particularly about the mathematical thinking threads as part of that strand. So as we worked on that task, which is called multiple surprises, it is on the NRICH site, we'll show you where shortly. Which of these mathematical thinking strands do you think, mathematical thinking threads, I should say, which do you think you could draw attention to, develop, help your students develop and get stronger at by working on this problem? Perhaps you could just take a few moments to contribute to the chat. I think we won't spend quite as long on this because we have done quite a lot of talking about it already. But which of these mathematical thinking elements would you say could be strengthened by working on this task with your students, and why? Thank you for your contributions on the chat. hopefully, I mean, as Tim, you said, I hope from some of the narrative as we were working on the problem will have helped sort of point you in the direction. We think this task really does lend itself to working on all five, not necessarily focusing on all five in, one lesson, but depending on the experiences your students have had already, or you think they would benefit from developing further, you can focus, you can draw out any of these five elements.
And of course, it doesn't mean that you're not tapping into mathematical mindsets, because there was a curiosity aspect about it.
Yes.
Someone said that you can work collaboratively by putting results up on the board. If you were having a go at the final question, you might have to be resilient because the answer may not be immediately obvious.
That's right.
But we're suggesting that the two problems that we've worked on today not only touch on aspects of the curriculum.
Yep.
So we're not focusing on conceptual understanding and fluency today, because actually textbooks do a pretty good job at that. But we're suggesting that rich tasks of this sort can strengthen students' understanding and fluency, while at the same time strengthening the other two strands.
Exactly.
That is why we like this rope model, that all three strands working together, supporting each other, contribute to the mathematicians who do have a positive mindset, who are able to think creatively, to justify and explain what they're doing, whilst at the same time having a good conceptual understanding.
Exactly. So hopefully you have got a sort of a better understanding of all aspects of our rope model. You've got some ideas about how to nurture your young mathematicians back at school. We'd just like to finish off the webinar by pointing you in the direction of several resources that we think you may find useful. We've used our rope model to structure the website. So if you go either to the primary teacher landing page or the secondary teacher landing page, there are analogous. Oh, let me just make this a little bit smaller. There we go. You'll see that the way it's organized is the left-hand box is curriculum linked. So here you will find our curriculum mapping documents. Here's the primary curriculum mapping document. And if I scroll down, you can see a link to less is more in the problem solving section down there. Here is our secondary curriculum mapping document. You'll find multiple surprises, the task that we just worked on, in the factors, multiples, and primes section. So if you are particularly wanting to focus, to choose a task based on its curriculum content, then that would be the place to go, in that left-hand box. But equally, we give you access here to tasks organized by mathematical thinking, and those are the 5 threads. And similarly, going back to the landing page to the mathematical mindsets, and you could alternatively access tasks because of wanting to strengthen a particular mathematical mindset. We wanted to draw your attention. If I just go to, I've chosen more, less is more here. Whoops. I can't see my own screen because I've got.
Put a link to the Nurturing Successful Mathematicians, to the rope model.
Thank you, Charlie.
In the chat.
Just to alert you to the fact, this is a relatively new development on NRICH, but at the top of every problem that you find on the mapping document, you will also find these little coloured circles. So it makes it very obvious which particular mathematical thinking thread on the left or mathematical mindsets on the right that you might want to develop using this task. These now, of course, these are very subjective, and just the questions you ask and the way you use it in the classroom could affect which of these you particularly address. But at least this gives you an idea. And just going back to the mapping document, here is the secondary mapping document as an example. At the top here, we've also introduced, you can do a little bit of searching via these 2 aspects too. So if I click the highlight problems box at the top, at the moment, you've got all our problems highlighted that link to those curriculum elements. But let's imagine you were particularly interested in the problems that we felt give you opportunities to develop exploring and noticing. You can see now that some of the problems are faded out, and the ones that you might want to look at for exploring and noticing are still in darker font. So do explore the problems that way as well. We mentioned that if you would like more information about our of each of these strands or each of these mindsets, probably the best place to go in terms of having them all collected together would be to go to our Problem Solving Schools menu and the Resources and PD page at the bottom. And here you will find, let me just make this a little bit smaller. There we go. At the top, a link to each mathematical thinking skill. Underneath each mathematical mindset, clicking on one of these takes you to a page of written guidance to help you understand what we mean by that aspect. And also you'll find recordings of previous webinars that we have organised specifically on that thread. Now, what have I forgotten?
We've put a link to the guidance at the bottom of our
We have indeed,
model.
yes. Let me just show you actually, what might be useful is if you wanted to find that the rope model image quickly, the best place, I think probably the easiest thing to do would be to go to one of the landing pages. I've chosen the secondary teachers one. Click on any of these three boxes and you will find a link at the top where it says Successful Mathematicians. That takes you to the article we've been focusing on with our model. Charlie just alluded then to the links at the bottom of the article take you to the pages that we've just been describing. We will be emailing you tomorrow with a link to an evaluation form. We would very much appreciate your views about the webinar this afternoon to help us do better next time and to give feedback to our funders. Thank you again to Trinity for the funding they provide. I think that has brought us rapidly to the end of this afternoon's webinar. We do have another webinar next week, which is all about our Problem Solving Schools initiative. So do join us for that. There's still time to sign up, should you wish. Charlie.
Somebody asked about the Productive Struggle book.
Yes, great.
I can't remember the names of the authors, but it's 3 authors. The book is called, I put a link to I haven't put a link. I've just put in the chat what the book is called. MATH, because it's written by Americans.
You'll find the full, I think if you go to the Being Resilient page, you'll probably find, I think you'll find a full reference to it at the bottom. But let's hope so. It should be down there somewhere. There we go, it's down there. Thank you all for participating. It makes our lives a lot easier if you contribute on the chat.
Yes. Thank you very much.
See you again soon. Bye.